Assalamualaikum. My name is Muhamad Zulhairie bin BADOVAIHIDO and my matrix number is S74468. For question 1, we need to find the descriptive statistic for the opening price of the data. So, this is the data of our gold data, and the first step is we need to arrange this data by ascending order. The next step is we need to find the mean, mode and median. To find mean of this data, we need to find the total for this data, which is 52,896. Then we need to divide the total with n, which is 20, and we will get the mean 2,644.80. For the mode, we need to count how many times each number appears. Since this data has no repeated numbers, the mode will be equal to 0. For median, we need to determine the middle number for this data. In this case, it is 10 and 11 position, which is 2,639 and 2,639.20. We need to plus that and then we need to divide with 2, and then we will get the median 2,639.10. The next step is 5 number summaries of the data. The first one is minimum. Minimum is the first position of the ascending order, which is 2,582.10, and then median, which we have calculated earlier, 2,639.10, and the third one is maximum, which is the last position of the ascending order, and that number is 2,725.10. The fourth one is first quartile. To find the first quartile, we need to determine the median of the data below the median, which is at the 5th and 6th position. And then we need to plus that numbers, which is 2,625.60 and plus with 2,629.40 divided by 2, and we will get the first quartile will be equal to 2,627.50. The third quartile, we need to determine the median of the data above the median, which is at the 15th and 16th position. We need to plus that numbers, same with first quartile, which is 2,652.40 plus with 2,658.30 divided by 2, and we will get third quartile will be equal to 2,655.35. This is the box plot of the opening price, and based on that previous 5 number summaries data, we can determine how to draw the box of whisker plot.
Hello, and my name is Muhamad dan NAZMI bin ZAINAL, and my matrix number is S76182, and I will present to you about question 2 and question 3. For this question 2, find the 98% confidence interval for the closing price of your data. Make your conclusion. For this question, we are using formula confidence interval for the population mean, and the interval uses T distribution. So this is the formula. Means minus T alpha over 2 times S over square root n less than or equal mu less than or equal mu mean plus T alpha over 2 times S over square root n. Step 1. We arrange the data, which is closing price. Then we calculate the mean of the closing price, and we get total is 2,647.73. After that, we find the standard deviation by each closing price, subtract with the mean, and square the result and sum them up. Then square root the answer, and we get 31.23. Next, we list out and calculate the information given. N is 20, alpha over 2 is 0.01, degree of freedom is 19. Step 2, we find the T value using the distribution, and since alpha over 2 is 0.01 and degree of freedom is 19, the critical value for 98% confidence level is 2.539. Step 3, we sub in information to formula and find the result. So 2,647.73 minus 2.539 bracket 31.23 over square root 20 less than mu less than 2,647.73 plus 2.539 bracket 31.23 over square root 20. Thus, the answer is 2,629.99 less than mu less than 2665.46. The result we got confidence interval is bracket 2629.99 and 2665.46. We can conclude that we are 98% confident that the true mean closing price of the population is between 2629.99 less than mu less than 2665.46. For question 3, find the 95% confidence interval for variance and standard deviation the opening price of your data. Make a conclusion. In this question, we are using formula that represent a confidence interval for the population variance by using chi-square distribution. Step 1, we arrange the data which is opening price. Then we calculate the mean of the opening price and we get total is 2644.80. Next, we calculate the sample variance and we get 1049.26. Then we list out the information given. Sample size n equal to 20, degree of freedom is 19, and alpha over 2 is 0.025. Step 2, we find the chi-square critical value using chi-square value table. Thus, we get x square upper is equal to 32.852 and x square lower we get 8.907. Step 3, we sub in the formula to find variance. So, 19 bracket 1049.26 over 32.825 and 19 bracket 1049.26 over 8.907. Thus, we get the answer is 607.34 and 2238.23. Next, to find standard deviation, we just square root the answer of the variance and we get the answer is 24.64 and 47.31. Last step, we can conclude that the 95% confidence that the variance is between 607.84 less than mu less than 2238.23, and we are 95% confidence that the standard deviation is lies between 24.64 less than mu less than 47.31.
So for question number 4, we are going to do a hypothesis testing on the closing price of the data, whether it changes or not at alpha equal to 0.05. So for the first step, we have to find the mean and standard deviation of the data. And from such, we got the value for mean is 2647.73, while standard deviation value is 31.233. After that, we go through the hypothesis statement, which is H null, mu null equal to mu1, and H1 mu null doesn't equal to mu1, which means that the closing price has changed. For the third step, we're going to find the critical value from the table for alpha equal to 0.05 and degree of freedom equal to 19, because for degree of freedom we need to n minus 1 and its sample size, which is 20. And from the table we got the value is negative 2.093 and 2.093. For the first step, we calculate the data using the formula T equal to mean minus population mean over standard deviation divided by set sample size. We input the value 2647.73 minus 2676.80 over 31.233 divided by set 20, and the result we got is 4.43. Since the value from the formula 4.43 is bigger than critical value from the table 2.093, H null is rejected. So there is enough evidence
to support that the closing price has been changed at alpha equal to 0.05.
So for question 5, to determine whether there is a significant difference between the opening and closing prices at a significant level alpha of 0.1, we use the dependent sample t-test. The null hypothesis, which is HO, states that the mean difference mu d between the opening and the closing prices is 0, while the alternative hypothesis states that the mean difference is not 0. With n equal to 20, the degree of freedom are n-1, which is equal to 19. Using a t-distribution table, the critical value for a two-tailed test at a alpha 0.1 are negative 1.729 and 1.729. From the data provided, the sum of differences is negative 58.6 and the sum of square differences is 8627.48. The mean difference is calculated as D equal to sum of differences over n, which is equal to negative 2.93, and the standard deviation of differences is computed as a SD equal to 21.10. The test statistic is then calculated using the formula T equal to D over to SD over to square root n, resulting in T equal to negative 0.621. Since this T value falls within the range of the critical values, which is negative 1.729 to 1.729, we fail to reject the null hypothesis. Thus, we conclude that there is no significant difference between the opening and closing prices at the 0.1 significant level.